Hi there, this is Professor Monty again. We're going to talk about rational and irrational numbers. Now, I started off, I talk about integers, and I've got another video where I talk about whole numbers and integers, but the integers are all the whole numbers and their opposites. So it goes forever to the left and to the right, but it's this pattern. It's the numbers that we typically think of as when we're counting things, and then all their opposites, or the negative of those numbers. Okay. A rational number is any fraction or a ratio where A and B, both the numerator and the denominator, are integers. B can't be zero. So you can never have zero on the bottom of a fraction that's undefined. So those are the rational numbers. So some examples, the number 5, any of the numbers that are integers are by definition rational numbers, because consider the number 5 would be in the set. And 5 is a rational number because we can write it as 5 over 1. Those are both integers, so 5 is a rational number. Any decimal that stops, or what we say terminates, can be written as a fraction. I've got another video where I show that any fraction that terminates or repeats is a rational number. I'll link that at the end of this video if you want to watch that. But the number 0.125 is a rational number because we can write it as 1 divided by 8. Of course, 1 and 8 are both integers. Similarly, 1.333 repeating with the 3's, also a rational number. We can write that as 4/3. Again, see my other video if you want to see how to do that. All right. The irrational numbers are just the numbers that cannot be written as the ratio of two integers. Simple as that. So some examples, some of the common ones we'll see, square root of 2. Now this is saying what number would I square or multiply by itself to get the value 2? Well, it's approximately the number 1.41, but if I multiply that by itself, I don't get exactly 2. There is no rational number that when I multiply it by itself, I get exactly 2. The same with the square root of 3. It's approximately 1.73, but it's not exactly. The number pi is another common number we'll see as an irrational number. It's about 3.14, but just like these other two numbers, the decimal expands forever. It never ends. It never repeats. It just keeps going with no pattern. Now, not all square roots are going to be irrational numbers. The square root of 4, for instance, is not irrational because the square root of 4 is 2. 2 multiplied by itself, 2 times 2 is exactly 4. And 2, of course, can be written as 2 divided by 1, so it is a rational number. So it's not that all the square roots are irrational, just the ones that don't simplify to essentially whole numbers. They can't come out negative unless there's a negative outside. Okay. But anyway, that's the idea. Work with these, practice a little bit, and there's some things we're going to be doing with these as we go on. But just practice with them, and you'll get more familiar with them, and you'll get it.